Perfect. So this is the second part of 5D, in which we will be discussing this third learning intention, which says to be able to divide terms and simplify the result. What I want you to do is come down to this page right here, in which it says simplifying fractions. Now, I know that you have simplified fractions last year in year 7, so I'm going to begin with a bit of a refresh. So remember, there are two ways we can simplify fractions. The first way I call the highest common factor method, and that is when we divide the numerator and the denominator by the highest common factor. So in this case, 16 and 24, that would be 8. So I divide both of these by 8. 16 divided by 8 is 2. 24 divided by 8 is 3. So my answer is 2/3. Now, another way of thinking about this is we could break up our numerator and denominator up into factors. So 16 can be broken up into 2 times 8, and 24 can be broken down into 3 times 8. Now what we can do is we could cancel out our common factors. So 8 and 8 are both common in the numerator and denominator, so we get rid of those, and now we're just left with 2 on 3. And that is our answer, 2 on 3. And that is what this line says right here. When dividing, any common factor in the numerator and denominator must be cancelled. So these are just two different ways of thinking about the same thing. Now, the other way to simplify fractions is the successive method, which is not as efficient. So in this method, what you would do is say, all right, I have 16, I have 24. I know both of those can be divided by 2. Which is going to leave me with 8 on 12. I then know that both of these can be divided by 4, which is going to leave me with 2 on 3. And as you can see, we get the same result. It just took more steps. So it took one more step there. And again, we could think about this in terms of factors. So this would be 2 times 4. Sorry, let's try again. 2 times 8. And then this one down here would be 2 times 12. And then these 2's would go away. I would be left with 8 on 12, which then could be further broken down into 2 times 4 and 4 times 3, in which these 4's would go away, and I'm left with 2 and 3. So as you can see, I really want to get your head around thinking about simplifying fractions in two ways. You can just divide the top by the bottom, or another way of thinking about it is you're breaking up the numbers into different factors and then cancelling common factors. This method right here is going to be really important when we introduce pronumerals into simplifying fractions. But before we do that, let's just talk about simplifying non-algebraic fractions. So these are fractions without any pronumerals. And again, there are two ways of thinking about it. The first way is simply going, all right, I can divide this by 3, I can divide this by 3, 3 divided by 3 is 1, 15 divided by 3 is 5, 1 over 5 is my answer. The other way of thinking about it is breaking it up into factors. 3 can be broken down into only 3 times 1, and 15 can be broken down into 5 times 3. I now cancel out my common factors, so 3 and 3, and I'm left with 1 on 5. As you can see, I get the same answer, just two different methods of thinking about it. Again here, 6 and 8. You could say I'm going to divide this by 2, I'm going to divide this by 2, which is going to leave me with 3 on 4. Or you could think about it as 6 is the same thing as 2 times 3, and 8 is the same thing as 2 times 4. I now cancel out my common factors, and I'm left with 3 on 4. Same answer, different method. Let's now answer two more questions like this. So if I have 8 on 12 and I want to simplify it, the way in which you should write it is you actually shouldn't write it as like divide and divide. Rather, the way in which you'll write it in later years, and what I really want you to start writing it now, is the way that the textbook writes it. And that is realizing that 8 and 12 can be divided by 4. So what you do is you just cross out that 8 and you go 8 divided by 4 is 2. And you cross out that 12 and you go 12 divided by 4 is going to be 3. So my answer is 2 on 3. That is the way you should be writing it. And again, if we wanted to think about this in our other way, we could say that this is the same thing as 2 times 4, and this is the same thing as 3 times 4, in which case those are going away, and I'm just left with 2/3. We can come over here and we can use this method again. So I'm going to cancel out that 12 and I'm going to say, well, let me think first. What goes into both 12 and 20? That's going to be 4. 12 divided by 4 is 3. 20 divided by 4 is 5. So that means I've got 3 on 5. Now we can come here, and another way of thinking about this is it's 3 times 4. And here, this is going to be 4 times 5. I've got those common factors there, which leave me with 3 on 5. Perfect. Now, before we move on, I just want to finally talk about simplifying the following, remembering that a over 1 is always equal to a. So what that means is any number divided by 1 is just equal to that number. So in this case right here, 28 divided by 7. Well, 28 divided by 7 is going to be 4, and 7 divided by 7 is going to be 1. So I've got 4 on 1, which is just the same as 4. So to over here, 54 divided by 6 is going to be 9. 6 divided by 6 is going to be 1. So it's just 9 on 1, which is the same thing as 9. So that's just an important thing you just need to remember. Okay, let's keep on going now. And let's come here. So now we're going to begin simplifying algebraic fractions. So now we're simplifying algebraic fractions. So everything we've done so far has really just been a bit of a refresher on Year 7 simplifying fractions. Now we actually get into the new stuff. So when simplifying fractions, what we do is we cancel out those common factors as we did before. The way to kind of show you this is we could add in the multiplication signs here. So we know that AC is the same thing as A times C, and AB is the same thing as A times B. We can now cancel out the common factors. So in this case, A, and I'm just left with C and B now. C and B. So to over here, I could add in my multiplication signs. And then I could say, hey, this x and this x are the same. So that means I'm just left with y on z. What's very important here is that this step right here actually isn't necessary. It's far more important that you just go from here to here, from here to here. And the way that you do that is just saying, hey, there's an x here, there's an x here, get rid of them. And now you're just left with y on z. So as we come to this one now, what you would say is I have an s here, I have an s here, which now just leaves me with r on u. So I'd go R on U. And just like that, I get my answer. Let's now come down here for a moment. Let's use our long method of adding in those multiplication signs. I know that X is the same thing as, well, just X, right? I can't break that up into any factors. And XY is X times Y. Well, it's clear that this X goes away and this X is going to go away. So I've got Y in my denominator, but what's in my numerator? This is important. So what you have to realize is that x can be broken down into x times 1, in which case this x goes away with that, and now I've just got a 1 on top. So to over here, let's use the quick method. This a will cancel with this a, this b will cancel with this b, this c will cancel with this c. So that means the only thing I have left is d in the denominator. But remember, whenever you're in this situation, you always have a 1 here, and that's because you can always times everything by 1 up the top. And now we come over here, this k will cancel with this k, this j with this j, this l with this l, and now as you can see I have a p left in my denominator. What's left in my numerator? That's right, a 1. Always a 1. You're not just going to have nothing in your numerator. Okay, let's come down here now. These are all similar. What we can do here is we could cancel this k with this k, in which case I'm just going to be left with a h in my numerator. And you know what? I might actually take a step back and do this one slowly. HK is the same thing as H times K, and K, we'll just leave that for the time being. So this K will cancel with this K, which means I'll have a H up here. And now you might be thinking to yourself, what's on the bottom? But remember, this K can be K times 1, which means that K is going to go away. Now I've got H on 1, and that means my answer is just H. So the quickest way to actually answer these ones is if this n cancels with this n and this l with this l, I just have an m in my numerator, which is m over 1, but that's just m. So to over here, this e will cancel off with this e, this f with this f, and because I just have a d left in my numerator, I know that my answer is just a d. I actually don't have to put in the step of d over 1. Let's keep on going now. So now we introduce squares here. So if I have a squared, that's the same thing as a times a, and that's going to be a times b in the denominator. These a's will cancel out, and I'll just be left with a on b. So as you can see here, what's actually happened is that this a has cancelled out with one of those a's up the top, which just leaves me with an a there. What I like to do in that case is just cross out that squared. Let's come here now. Again, we could write this out. We could go, this is b over a times, now b squared is b times b. So this b is going to cancel off with this b. Remember, you're not just going to have nothing in the numerator in this instance. There's going to be a 1 there. So I'm going to be left with 1 over ab. And finally, we come to this one, in which we have f squared over e squared f. This is going to be, well, what's going to happen here? One f here is going to cancel off with one f there, which means I'm just going to have an f here, and then I just have an e squared there. So just be careful with how you approach these. If you are feeling stuck, you can write them out, multiplying each one, but after a while, you'll become efficient enough where you can just start canceling things like that. Okay, let's keep on going now. So now we're actually going to combine together some numbers and the pronumerals. Again, we can think about this the long way, in which we are breaking them off into factors. So here, this is the same thing as 4 times x. And here, this is the same thing as 2 times 4 times x, because this 8 can be broken down into 2 times 4. This x will cancel with this 4 with this 4. So what I'm going to be left with is 2 down the bottom. And remember, when you have nothing up the top, there's just a 1 there. So 4x over 8x is the same thing as a half. Now, the way I want you to answer these things is not by drawing these out. Rather, I would much prefer you to do it this way. You see an x there, you cancel them. Then you've got a 4. 4 divided by 4 is 1. 8 divided by 4 is 2. And therefore, you just get a half. So it's a lot quicker this way, and this is the way you should be doing it. You shouldn't be writing them all out. Rather, you should just be doing this method. This is really just to show you what's going on. And let's just do it one more time. So if I was to do this, this is going to be 4 times 7 times a times b over 7 times a times c. This 7 will cancel with this 7, this a with this a, which is going to leave me with 4b on c. That's going to be my answer. But again, the way that I want you to do the working is simply go, there's an a, there's an a. This divided by 7 is 1. This divided by 7 is 4. So that means I'm going to be left with 4b over, now I don't have to put that 1 because 1 times c is just c. So that is my answer, just like that. Perfect. Let's now just start doing it the quick way. So in this instance right here, can I cancel out any of my pronumerals? No, because this is an A and this is a B, so they can't be cancelled. I have a 7. 7 divided by 7 is 1. 21 divided by 7 is 3. So my answer is going to be A on 3B. Remember, 1 times A is A, so I don't have to put that 1 there. Let's come over here now. Here, I have an N there and I have an N there. They cancel out. Can 9 and 4 be divided by a common number? No, they cannot. So that means I'm just left with 9m on 4. Let's come to our next one. Here we have 27, AB, 18, BC. Well, I see a B and a B. They can both be cancelled. 27 and 18 can both be divided by 9. 27 divided by 9 is 3. 18 divided by 9 is 2, which means I'm going to be left with 3a on 2c. Let's now come over here. I have 24 MNP divided by 6p. Well, I see a p there and I see a p there. They both can go away. 24 and 6 can both be divided by 6. 6 divided by 6 is 1. 24 divided by 6 is 4, which means I'm going to be left with 4mn over 1. And remember, whenever you're dividing by 1, your answer is just going to be whatever is your numerator. So 4mn in this case. Perfect. Let's keep on going now, and this is now the last page in which we're going to be talking about how powers and signs come into play. So it says simplify the following expressions, and I'm going to actually write this out the long way first. So this 15z over 20z squared could be written like this. It could be written as 3 times 5 times z. So I've broken up that 15 into 3 times 5, and this 20 could be written as 4 times 5. Now I've got a z squared here, so that would be written as z times z. And now we just cancel out our common factors. This 5 will cancel out with this 5, this z with this z. So now what I'm left with is 3 over 4z. So I'm just looking at what remains, 3 over 4z. But remember, the way in which I want you to approach this is go, all right, I have z here and I have z squared there. So this 1z will cancel out with one of these z's, so I'll cross off that squared. And then I've got 15 over 20, both of which are divisible by 5. 15 divided by 5 is 3, and 20 divided by 5 is 4. So that means I'm left with 3 over 4z. And just like that, I get the same answer. Let's come over here now. And as you can see, I've got signs here. So I've got two negatives. Remember, when you're dividing two negatives, what's your answer going to be? Negative divided by a negative is going to be a positive. So I know that my answer is going to be positive here. And the way I like to think about it is the two negatives cancel out with each other. Okay, let's keep on going. If I've got 12 and 15, both of those are divisible by 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. I then have p squared and p. Well, this p will cancel out with one of these p's here, which means what I'm going to be left with is 4p over 5r. And it's positive because those two cancelled out there. So that's the quick way to do it. And hopefully by now you're feeling pretty confident with doing it that way. But if you're not, remember, you always have the alternative of doing it the longer way. But it isn't recommended because it does take some time here. So in this case, what you would end up doing is immediately I'm just going to cross out those negatives because I know they just go away. Then you'd have to go, all right, I have 3 times 4 times p over this is going to be 5 times 3 times p times r. This 3 will cancel out with this 3. This p will cancel out with this p, which means on top I've just got 4 and p, and on the bottom I've just got 5 and r. You can see how much longer that way takes, and that's why it's not recommended. You need to get good at just doing it that way. And now for the rest of the questions, we're just going to do it that way as well. All right, so 27 AB over 18 BC. And as you can see, I have one negative. I've got negative divided by a positive. So I immediately know that my answer is going to be negative because a negative divided by a positive is going to be negative. All right, now I see a B there and a B there. So they go away, they cancel. Easy stuff out of the way first. If I've got 27 and 18, I know both of those are divisible by 9. 27 divided by 9 is going to be 3, and 18 divided by 9 is going to be 2. So my answer is going to be negative, because I've got a negative there, then 3a over 2c. That's going to be my answer. Let's come over here now. I have 18a squared b over 8ac. I know that 18 and 8 are both divisible by 2. 18 divided by 2 is 9, and 8 divided by 2 is 4. I've got a squared and a. This a will cancel out with one of the a's up the top, but I've still got one left there, so I've just cancelled out that square, and then b and c, nothing can be done there. So I'm going to be left with 9ab over 4c, and that's going to be my answer. Okay, let's come down here now. So here we've got 10ab over 2a squared c. How are we going to answer this? This is going to be, well, 1a here is going to cancel out with one of the a's on the bottom. This 10 and this 2 can both be divided by 2. 10 divided by 2 is 5. 2 divided by 2 is 1, which means I'm going to be left with a 5b over, now I've got 1c, but I'm not going to put that 1, I'm just going to put c there, and that's my answer. Let's come over here. As you can see, I have a positive divided by a negative, so I know my answer is going to be negative. I've got y squared and y, so I know this y will go away, and I'll be left with 1y up the top. I've got 12 and 18, both of which are divisible by 2. Yeah, let's go 2. 12 divided by 2 is 6. 18 divided by 2 is 9. Whoops, they can be divided by 3. See how I noticed that? 12 divided by 3 is going to be 4, and 18 divided by 3 is going to be, am I just having a dumb moment right there? It's going to be 6. 18 divided by 3, so that means there's something else that these two can be divided by, and that's going to be, oh, they're both divisible by 6. Oh my, this video has been going on for too long. 12 divided by 6 is 2, and 18 divided by 6 is 3. I'm not re-recording this. This is taking too long. Oh, so that means I'm going to be left with 2y over 3. And it's a negative because I got a negative there. Okay, so make sure that you're thinking correctly when you come there. All right, last ones. I think I'm going to cut some of these out for the real lesson. If you've made it this through far in the video, you've done well. All right, so here, this p will cancel out with this p. This negative will cancel out with this negative. And 40 and 32 are both divisible by 8. 40 divided by 8 is going to be 5. And 32 divided by 8 is going to be 4. So my answer is going to be 5 on 4. Perfect. We come over here. I've only got one negative, so I know my answer is going to be negative. I've got a y and y squared, so one of these y's are going to go away. I then have z and z squared, so one of these z's are going to go away on the bottom. And then that means I'm going to be left with 15 and 20, both of which are divisible by 5. This will be 3, this will be 4. So I'm going to be left with 3y over 4z. Perfect, and that's going to be my answer. Alright, so hopefully you found this video useful. For the actual lesson, I think I'm going to take out some of these questions. I think there's too many questions. But if you are watching this video as a bit of a refresher, more questions the better. So hopefully you found this useful, and I will see you in the next lesson.